And that microcontroller is going to be super tiny, custom microcontroller setup where it's basically just the size of a chip. I'm stripping out all the extra materials to be tiny SMD components mounted on top of the chip. And that's something I'm pioneering. Like normally, let me show you guys a drawing of what I mean by I'm pioneering something new here. Most people will do this. You'll have, here's like a microcontroller chip, and then it's got like its little pins or whatever. And then most of the components are like littered around a huge area, and then there's like a big board around it, right? It's like that. And all these components are spread out. Well, what if you could fit all the components onto the chip on like a very thin piece of flat flex cable, like a super thin circuit board that's made of Kapton tape with copper electroplating on it, instead of a, I guess they're called FRC circuit board or whatever, like instead of a fiberglass thick circuit board, it's like paper thin. It's literally paper thin. It's 0.1 millimeters thin. So your circuit board actually is mounted on top of your chip, and all of your little SMD components like resistors and capacitors, bypass capacitors, whatever you need is like all on that little circuit board. And then that circuit board has like little fingers that will reach out to the pins or something like that, and then the pins will run off in every direction. Or the circuit board could even be just covering this whole thing, and be soldered to the back side of the chip, and then have like little pads where you solder the chip. So basically it's two-sided circuit board. So the front side has like your pads to mount the chip, and the back side has all your components. So it's a two-sided circuit board. And then it forks off as ribbons in either direction, like ribbon cable, which you can fold up and guide in one direction so that everything will flow just this way or just that way. All four groups of electrical lines coming off the pins can all run in one direction. And I've already done an example of this, which I can show you guys here. I soldered, this is an Atmega2560 microcontroller chip, and I soldered flat flex cable to it. And you can fold all this cable to run it like all in one direction, so that like actually fold it tight to the chip. I don't want to fold it now because I want to like think about it before I do anything, but you could have them all run one way and just have the chip here with all the cables running like in one direction. And so that way you'd have like all your little components that are needed, like bypass capacitors and stuff, and your ceramic crystal and stuff could all be on top of the chip, so that the entire form factor of your whole microcontroller is just about the size of the IC itself. As compared with, if you look at an Atmega2560 Arduino board, it's this big. And mine is going to be literally just the size of the chip itself. Theirs is this big. It's this big. The header pins are spaced out. Like, it's huge. And where would that fit in my robot? And what if I want to have like 50 or 60 of these in my robot to handle all the motor control and sensory input and analog input pins? Like, I'm going to need a ton of these. I'd be screwed. So that's why we're doing it this way, with like a bare minimum, super tiny microcontroller type of setup. That's why we're going to do that. Let me read chat. Just catch up. How many of these do you need?